Now, let's actually dig into one of these optimization problems. This one is a little bit lighter than some of the stuff you might find in our textbook. My concern for this problem is I have a succulent, just some little relative of a cactus. And though my succulent does need light, it can only take so much before it, has too much light and withers up and dies. So I'll have some potted succulent in my living room, say, and I would like to place it in the position where it receives the least amount of light. Of course, I'm not just going to put it away in a hall closet or something. I actually want it in the room to improve my decor. Now, the setup for my living room is that my living room is 10 feet across. On the one side of it, I have just a simple lamp. And on the other side of it, I've got a window. And I'm just going to draw a sketch. It doesn't have to be too fancy, just to give myself an idea of what's going on here. So maybe here's a lamp and here is a window. Now, in order to apply calculus to this problem, I need to actually understand, right, how to quantify what's going on. So as maybe I want to move my plant farther away from the window over here, and that will reduce the amount of light that's coming in from the window that manages to make it to the plant. But now more of the light is able to make it to the plant coming from my lamp. In order to actually quantify what's going on, I am borrowing a little bit of wisdom from, say, physics. This bit here about the light received is inversely proportional to the square of the distance. So as I build a numerical model, what do I mean by model? Just a formula, some function that will help me understand what's going on with numbers. I want to build up a formula that describes this situation. So I'm not actually told how bright this lamp is. Not even sure what units I'd be using. Maybe lumens if you look at a light bulb these days. For right now, I'll just call the amount of light, the amount of brightness this lamp has, L. And I know from the statement of this problem that the window is actually 3 times as bright as the lamp. Okay. So now wherever I put my plant between the window and the lamp is going to determine, well, 2 different distances. So wherever my plant is, there will be a distance between the plant and the lamp, and there will be a distance between the plant and the window. So maybe I can call those X for the distance between the lamp and the plant, and I'll call Y the distance between the plant and the wall. So this tells me the amount of light received by the plant. Well, this is going to be equal to, I've got how much light does the plant receive from the lamp? And then I'll add to that the amount of light the plant receives from the window. So let's actually build a formula for that.